In this session, I'm going to build a mechanism known as do-nothing grinder. So to start, we need two sliders. So let me just bring a fixed point. For the sliders, I'm going to be using the prismatic joint. So I am going to orient one in X and the other one in Y. So I'm going to connect them to the base or to my fixed point. I actually have to adjust my settings. So I am going to set my gravity to -Z, so that my orientation is Z up. Okay, so that's my two degrees of freedom. So let's put the actual sliders there. I'm going to use the machine element block. So 0.3 for this guy and another copy. This one is moving in Y, and I will orient this in Y as well, and 0.3. Now, if we run this model, nothing special will happen because gravity is perpendicular to the degrees of freedom for these sliders, so they will not move, but we'll get a sense of what we are dealing with. Okay, so let's zoom in. So these are the two blocks. The starting point of both of them are at 0, 0. Okay, so the thickness of them is 0.1 meter. So what I'm going to do is just have a nicer animation. First of all, activate the additional frame, so it will give me one frame in the middle, and that's where I'm going to put the connecting rod, but I'm also going to put that a bit higher. This is a planar system, so the elevation wouldn't change anything, but I'm going to make that 0.1. So we are going to go a little bit higher on that. And same for this one. So now these two frames are in the middle of these two sliders, but on the top of them. And I am going to use a bar. But before that, I need revolute joints, and these revolute joints, I want them to be in Z. And that's the case. There we go. Now we'll just connect this together. So that's our system. What I'm going to do is set that to enforce and give it an initial velocity of 1 meter per second. Oh, before doing that, again, just for the sake of animation, I'm going to make this different color so that we can see it better. And let's see what we get. There you go. And since we have not included any losses, this motion will continue as long as we simulate the system.